This is Ham College, episode 112, for April 26, 2024. Ham College is brought to you by Icom. The wait is over. Come see Icom at Hamvention 2024 in Xenia, Ohio from May 17th through 19th. Also, you won't want to miss a sneak peek of an upcoming mystery radio release. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got questions tonight. Speaking of that, we're just about out of questions.
Yeah, we got one more show's worth, don't we?
After this, and then we'll have covered the whole extra class amateur pool. So it's
get your pencil,
yeah.
Get your pencil sharpened, get ready to take your test.
Yeah, it's getting close to time. And you're going to need to get on it because the exam pool is going to be expiring
Shortly
pretty
after.
soon. Yeah, June the 30th.
More than 2 weeks.
Yeah.
You got all kind of time.
I don't know about that, but
You got time to go to Dayton and take your test.
I got something I wanted to mention here. Probably a lot of you have already heard about this in the last couple of days.
Oh, man, I need to get a tissue.
Yeah.
I hate that.
This is a letter from Martin Jew, posted yesterday, April the 25th, 2024. Dear fellow hams and friends, it's with a sad heart as I write this letter. As many of you have heard by now, MFJ is ceasing its on-site production in Starkville, Mississippi on May 17th, 2024. This is also the same for our sister companies, Ameritron, High Gain, Cushcraft, Mirage, and Vectronics. Times have changed since I started the business 52 years ago. Our products lines grew and prospered. COVID changed everything in businesses, including ours. It was the hardest hit that we've ever had, and we never fully recovered. I turned 80 this year. I'd never really considered retirement, but life is so short, and my time with my family is so precious. I want to thank all of our employees who have helped build this company with me over the years. We have many employees who have made MFJ their career for 10, 20, 30, 40 years or more. We're going to continue to sell MFJ products past May 17th, 2024. We have a lot of stock on hand, and we'll continue to offer repair service for out-of-warranty and in-warranty units for the foreseeable future. Finally, a special thanks to all our customers and our dealers who have made MFJ a worldwide name and a profitable business for so many years. You are all so much appreciated. Sincerely, yours, 73's, Martin F. Jew, K5FLU. Well, we're really going to miss MFJ, and yeah, we'll see what the next chapter is.
Yeah, I'm not really sure what that means. It's I don't think they're just gonna disappear off the face of the earth. At least that's my interpretation of it. But we'll just see what happens.
Yeah.
I really don't know.
Yeah, we don't have any inside information or anything like that. But
I can understand Martin wanting to retire and stuff. But
yeah, well, it's such a big operation that, like we were talking earlier, it'd be difficult for any one ham radio company to take it all on.
oh yeah,
So
it's huge.
maybe some of the various lines will get picked
What's
up
he
by
got?
others.
He's got the MFJ stuff, High Gain, Victronics, Ameritron, Cushcraft.
Yep.
He saved so many places that would just been, those companies
Yeah.
would have been just completely gone.
And I wouldn't be surprised if somebody didn't pick up, some
Yeah.
of this. It would only make sense, but we don't know. So we'll just have to see. Well, Tommy, what did we talk about in the last episode?
Let me see. Smith charts.
Smith charts.
Smith charts. It impressed me so much I did an Amateur Logic segment on it too afterwards.
Yep, you did. And I still feel like we only scratched the surface.
Yeah. But I think we scratched it enough.
We scratched it enough to get through, yeah. This month we're going to talk about receiving antennas. radio direction finding antennas, beverage antennas, specialized receiving antennas, and long wire receiving antennas. So,
Beverage antennas. Every time I hear that, it makes me thirsty.
that's not what we're talking
That's
about
not
here
the
tonight.
one Jimmy made.
No, it's not. One can at a time.
Yep. I'm not sure I would have remembered that one if we'd have made
No.
one like that.
I don't remember seeing it.
The Youth on the Air will be accepting Eclipse glasses donations. These recycled Eclipse glasses will be sent home with Argentinian campers attending the 2024 Youth on the Air Americas Camp so that amateur radio operators and youth can safely watch the annual solar eclipse in October of this year. This is a great opportunity to recycle your unused or gently used glasses while helping your fellow amateur radio operators and youth in the hobby. Donations will be accepted in person only at the Dayton Hamvention Youth on the Air booth, number 4304, from May 17th through the 19th, and at the 2024 Youth on the Air Americas Camp in Halifax, Nova Scotia, Canada, from July the 7th through the 12th. For more information, you can visit youthontheair.org/Halifax2024. That link will be in the show notes.
First question up tonight. This is not that bad a question, I don't think.
Good.
When constructing a beverage antenna, which of the following factors should be included in the design to achieve good performance at the desired frequency? A, its overall length must not exceed 1/4 wavelength.
B, it must be mounted more than one wavelength above ground.
C, it should be configured as a 4-sided loop.
Or D, it should be one or more wavelengths long. Overall length must not exceed 1/4 wavelength. I don't think that's not right. When constructing a beverage antenna, which of the following factors should be included in the design to achieve good performance at the desired frequency? Must be mounted more than one wavelength above ground. That could be pretty high. Should be configured as a 4-sided loop, or it should be one or more wavelengths long. I'm gonna go with D on this one. I'm
Okay.
not sure. I don't think it should be less than 1/4 wavelengths long, or only a quarter.
I concur, as well as just about everybody in the chat room there. Well, practically everybody, except email. He said it's a alcoholic beverage antenna. You build it one can at a time. But anyway, no, I'm pretty sure you're right.
How many 12 packs does it take to build a beverage antenna?
Yeah, quite a lot, because you got to have more than one
It's got to
wavelength.
be more than one wavelength long. It's going to be a lot.
That's a picture of a beverage antenna. You can see the top wire there. It's got to be one wavelength or longer. And you've got to have a counterpoise wire across the bottom, or at least this design did. I don't know if you could do it by using a ground rod or
and
not.
that kind of looks sort of like the thing I told you I saw Jimmy had out there at his place. So I guess that
Really?
is what he had.
It probably is then. And you terminate the opposite end of it from the feed with a 400 to 600 ohm resistor. You know, I've been wanting to make one of those myself. It just seems like it would be a fun project.
Yeah.
And it'd be nice to really be able to reach out and hear some stuff that otherwise you couldn't.
I think he had you remember that AOR receiver
Yeah.
he had? I think that's what he had it hooked up to, if I'm not
You might,
mistaken.
yeah.
I'm pretty sure.
I really want to try that. You know, I've got room up in the country to do that.
Yeah. That thing's awful low, though, man. You got to be careful when you cut the grass.
Well, I couldn't leave it
You
there.
clothesline
Yeah.
yourself.
The guy who cuts the field for hay would,
Yeah, he wouldn't be. He'd be pretty mad
yeah.
after he got back from the hospital.
But, you know, if you had your wires cut and all, it wouldn't take long just to string it up, tie it across there. I may try that one day.
Yeah, it'd be
I
fun.
don't know.
Fun.
Wires gotten so expensive. That could be expensive antenna to say if you ran,
If you ran it over one wavelength long.
well, or several, which is better.
Which is generally true for low band 160 and 80 meter receiving antennas. A. Atmospheric noise is so high that gain over a dipole is not important.
B. They must be erected at least 1/2 wavelength above the ground to attain good directivity.
C. Low loss coax transmission line is essential for good performance.
Or D. All of these choices are correct. Which is generally true for low band 160 meter to 80 meter receiving antennas. Well, I'm going to knock out C. Low loss coax transmission line is essential for good performance. No, at 160 meters and 80 meters, you're not going to have that much loss in your coax. So we can strike C out. Yeah, low loss be good.
It's receiving anyway, too.
But it's low loss is not real. Well, you'll have loss, whether you're receiving or transmitting, but it's not that important out on those frequencies because coax just not going to have as much loss there. So we can knock out C and D right away. B, they must be erected at least 1/2 wavelength above the ground to attain good directivity. No, you may not be building an antenna for directivity, would be one thing, and a 1/2 wavelength above ground. A 1/2 wavelength at 80 meters, that's pretty high. Might be nice to have it up there, but I don't think it's not required to be at least that high. A, atmospheric noise is so high that gain over a dipole is not important. That's going to be the answer because atmospheric noise is pretty high on 160 and 80.
It's horrible. That's why I hardly ever get on there on 80.
Yeah, if you want to talk at night, though, yeah, that'd be some on 40, but 20 goes out usually pretty early. Atmospheric noise is so high that gain over a dipole is not important. So I'm going to say A. What do you think?
I think it's A also.
Yeah. A little mix in the chat room there. And it is A. But I'm inclined not to 100% agree with that. We were just talking about building a beverage antenna.
Yeah.
You're building that beverage antenna because it's got so much directivity. That's the reason you use it, because, it's got such high directivity to it. So that is going to be gain over a dipole. And that seems like it's important, in that particular kind of antenna.
Guess it's a little contradictory, isn't it?
Yeah, it seems that way, but A is the answer. And I'm going to say that, which is generally, and I think generally is, that's the qualifier there. What is the receiving directivity factor, RDF? A, forward gain compared to the gain in the reverse direction.
B, relative directivity compared to isotropic.
B, relative directivity compared to a dipole.
Or D, forward gain compared to average gain over the entire hemisphere. I'm going to go with A on this one. That's the one that seems to make sense to me somewhat. It may be wrong.
They don't really know.
Nobody's answering. You guys, come on, guys.
Well, they're answering, but they're saying not really sure.
Well, I'm not really sure either. I'm thinking it's A, though.
And that would seem to make sense.
But
I don't think that's the right answer.
It may not be.
And most people are saying, well, it's kind of tied between A and D.
Directivity compared to a dipole. Then maybe it's C. I really don't know. What's the answer? Come on, the anticipation's killing me. None of the ones I thought.
Forward gain compared to average gain over the entire hemisphere. D. Well, that makes sense too. It must. That's the answer. So.
Okay. So we got one buzzer.
Yep.
What is an advantage of placing a grounded electrostatic shield around a small loop direction finding antenna? A. It adds capacitive loading, increasing the bandwidth of the antenna.
B. It eliminates unbalanced capacitive coupling to the surroundings, improving the nulls.
C. It eliminates tracking errors caused by strong out-of-band signals.
D. It increases signal strength by providing a better match to the feed line. What is the advantage of placing a grounded electrostatic shield around a small loop direction finding antenna? I have built loops with shielded cable before. I'll start at the bottom. D. It increases signal strength by providing a better match to the feed line. No, doesn't do that. C. It eliminates tracking errors caused by strong out-of-band signals. I'm not even sure what that means.
I don't know.
Tracking errors and what would that be? And
that seems kind of like a wordy
yes,
diversion.
I think it's C. B. It eliminates unbalanced capacitive coupling to the surroundings, improving the nulls. It's a possibility.
That seems plausible.
A. It adds capacitive loading, increasing the bandwidth of the antenna.
You really don't want to increase the bandwidth, do you?
Well, depends on how many frequencies you want to pick up, but it's either A or B, and I'm going to say it's B. It eliminates unbalanced capacitive coupling to the surroundings, improving the nulls. Because anything that could improve the nulls would be important.
Okay.
Chat room, well, they're kind of liking B.
Yeah, I kind of like B, but honestly, I really don't know. I think it's either A or B, but I think it's probably more likely B than.
And it is. Basically, it's just a loop. Now we've got one side grounded and the other end's going to our receiver. And you just use shielded cable. You could use coax, but you only connect it at one end. So you can see on the left side there, the coax shield and the center conductor are connected together and grounded on that side. And the other side goes on to the antenna and put on our receiver. In truth, there might be a capacitor or some type of matching network there. Not always, but that's a simple shielded loop. And the reason to use that is
Because
to decouple it from the things in the environment. Because if you just built a loop out there, it's going to be capacitively coupling to the ground or maybe a tree that's nearby or whatever. And putting the shield around it helps to eliminate it coupling with those other sources, so it's acting more like a real loop without outside influences.
Cool stuff.
Yeah. I have, well, I don't know where it is now.
Yeah, I was just looking at that one too.
Yeah, that one's not a shielded loop, but you know, I built a shielded loop a few years ago out of a hula hoop.
Yeah.
And some wire, and make good AM receiving antennas. What is the main drawback of a small wire loop antenna for direction finding? A. It has a bidirectional pattern.
B. It has no clearly defined null.
C. It is practical for use only on VHF and higher bands.
Or D. All of these choices are correct. Well, it's got a bidirectional pattern. That's a plus for sure. No clearly defined null. I don't think that's true, is it? Practical for use only on VHF and higher band. I'm going with A.
That's what everybody's. I think everybody in the chat room is saying that, and it is.
A. the Canadian answer.
Yeah, and
Mike in there?
if you think about a loop, I mean, that's the answer. It's just, two circles. That's not really, I can't do it with my fingers.
That's a nice try.
Yeah. It's two circles, so there's a null right where the two circles meet each other. And it's bidirectional. There's one on both sides.
Yeah, that's why I didn't think it's when I said it has no clearly defined null, I don't think that was true. But,
No, it's pretty good null. But there's two of them. It's bidirectional. And the thing about it's practical for use only on VHF and higher bands, that's not true because, you can get HF loops that are just, about that big. Like the Alex loop and some of those.
That alpha thing.
Yeah, those are for
Greyhound.
HF.
Yep. What is the triangulation method of direction finding? A, the geometric angles of sky waves from the source are used to determine its position.
B, a fixed receiving station plots 3 headings to the signal source.
C, antenna headings from several different receiving locations are used to locate the signal source.
Or D, a fixed receiving station uses 3 different antennas to plot the location of the signal source. What is the triangulation method of direction finding? I think most people will get this if some of the crafty wording and some of the others doesn't throw them off. Starting with the bottom there, D, a fixed receiving station uses 3 different antennas to plot the location. No. If you're sitting in one spot, you can have 3 antennas, but that's not going to really tell you so much where the station is located. C, antenna headings from several different receiving locations are used to locate the signal source. That sounds like it could be it. B, a fixed receiving station plots 3 headings to the signal source. How could a fixed receiving station plot 3 headings to the signal source? How could you do that?
Well, 2 of them would have to be wrong.
Yeah, unless they were all the same. No, it said different. Yeah, that's impossible. I don't think you could do that. A, the geometric angles of skywave from the source are used to determine its position. You couldn't really know the geometric angle of a skywave signal. I guess you could. Yeah. No. And direction finding doesn't work great on skywave either. See, everybody's saying that over in the chat room. So it's got to be right.
It's got to be. Yep.
And it is. Okay.
If they all answer, it's pretty good chances right. But if they hold back and they hardly any of them say anything, that's a tough one right there.
What do you say we take a break, come back?
So soon?
Yeah, that's about halfway through. The wait is over. Come see Icom at Hamvention 2024 in Xenia, Ohio from May 17th through 19th. Also, you won't want to miss a sneak peek of an upcoming mystery radio release. Upgrade your station with one of Icom's fabulous HF radios. With the IC7610, faint signals are no longer challenging for DXers and contesters. The high-performance RMDR can pick out the faintest of signals, even in the presence of stronger adjacent signals. This is the SDR every ham wants. With Icom's IC905, VHF contesting is a breeze. This all-mode rig covers 5 bands with 1 radio. 2 meters, 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz bands, and with the optional CX10G transverter, 10 gigahertz. Large color touchscreen, easy D-Star settings, and a separate controller and RF module configuration to reduce signal loss. Explore the world of microwave with the IC905. The IC705 and IC7300 are the perfect go-to rigs for outdoor hams who love POTA and SOTA activations. Both radios feature a large touchscreen with real-time spectrum scope and waterfall for intuitive function and setting operations. The IC705 provides base station features and performance in the palm of your hand from HF to 50, 144, and 440 MHz. The IC7300 is an industry first, using RF direct sampling in an entry-level HF radio. If you're getting a head start on hurricane season, Icom's IC7100, ID5100, ID50, or ID52 are the perfect traveling companions and should be on your go-kit list. From high-powered base stations to compact and travel-friendly handhelds, Icom radios offer in-demand features and functions to keep you active on all bands, inside your shack or out in the field. For more information about Icom's amateur radios, visit icomamerica.com/amateur today. What do you say we give away something?
Hey, well, look what I found. How about this? It's a cool shirt, man.
An Icom Ham Crew t-shirt.
Look just as good when you leave the ham fest as you did when you got there. I need to patent that slogan. All you got to do is send an email. hamcollege@AmateurLogic.TV. You don't even have to put a note in there or anything. You just need an email address and a name.
Well, just moments ago.
No.
Yes. We did a drawing to see who was going to be this month's lucky winner. We went to hamcollege@AmateurLogic.TV and looked at the email addresses, and the random winner is Stu Kirker. He says, please add my entry to your list for the t-shirt. Stu Kirker, W8SDK.
Congratulations, Stu.
This is your question. Why is RF attenuation used with... Say it again. Why is RF attenuation used when direction finding? A, to narrow the receiver bandwidth.
B, to compensate for isotropic directivity and the antenna effect of feed lines.
C, to increase receiver sensitivity.
Or D, to prevent receiver overload, which reduces pattern nulls. To narrow receiver bandwidth. RF attenuation. No. To compensate for isotropic directivity. They're really on the isotropic thing tonight.
Well, it's a big word.
And the dreaded antenna effect of feed lines. Now, I don't think that's the problem here. I don't think that's the answer. Increase receiver sensitivity. Well, that's kind of the opposite. Well, not the receiver, but the coming in. Anyway, D, to prevent receiver overload, which reduces pattern nulls. I'm going with D on this one. That's my final answer.
I think that's a good answer. Chat room? Yeah.
Everybody's got the D.
Yep. And Jeff stated a Holiday Inn Express. Oh, that doesn't count. That's what he said. Okay. Let's see. D. All right.
Cool.
That makes sense because if the receiver's being overloaded, it's kind of hard to tell where the null might be.
What is the function of a sense antenna? A, it modifies the pattern of a DF antenna array. I guess that's direction finding. Antenna array to provide a null in one direction.
B, it increases the sensitivity of a DF antenna array.
C, it allows direction finding antennas to receive signals at different vertical angles.
Or D, it provides diversity reception that cancels multipath signals. What's the function of a sense antenna? Provides diversity reception that cancels multipath. Well, diversity reception does help cancel multipath signals, but that's not what a sense antenna is. C, it allows DF antennas to receive signals at different vertical angles. I don't see where that would be helpful. B, it increases the sensitivity of a DF antenna array. No. A, it modifies the pattern of a DF antenna array to provide a null in one direction. That's going to be my answer.
Yeah. It's A, eh?
Yep. You want some splaining?
Sure.
I just happen to have 3 pictures here.
Photos?
Just happen to have. No, they're all drawings. Sorry, I don't have any photos tonight.
Oh, man.
That straight line through the middle is the direction of the loop. In other words, if you're looking down on the loop, this is what you would see. That bar across there, that's the top of the loop.
Yep.
So these 2 lobes out on either side are what you would see with the loop. Coming off the ends, you've got a stronger signal. Coming off broadside, you've got those nulls, and there's 2 nulls there. If you get on, you don't look through the hole in the loop and say that's the way the signal's going. No, you turn it to where you're looking down the plane of the loop. Yeah, and that's the kind of pattern you get. You got 2 nulls there. For direction finding, you can't, well, you could try using, say, the ends or the lobes where the most signal is, but that's kind of broad.
Yeah.
You know, it'd be hard to zero in.
Yeah, it's best to find it where you kind of lose the signal.
Yep. Rather than tell where the signal is, you can tell where it's not. If you null it out, then you can just look down the null and you know that that's the direction it is. The only problem is that's a loop antenna and it's got bidirectional nulls. There's 2 different nulls there. Say if we're looking north, south, east, and west here, there's a null to the north and a null to the south. So how would you know which direction? You know it's either north or south, but you can't tell which. If you took a small vertical antenna, and let's just lay its pattern on top of the loop, say it was sitting right in the center there, it's just a circle. It goes all the way around.
Mm-hmm.
However, if we had the loop and we had the vertical antenna, and we'd call the vertical antenna a sense antenna, if we took the output of the 2 antennas and combined them together 90 degrees out of phase with each other, would get a cardioid pattern. And then there's a pretty sharp null on that cardioid pattern on the
let's say
on the left side there. So then you could tell which direction. In other words, the first thing you would do is use the loop, and then you would find the null with it. And say in this case, we see it's either north or south of it. That's where the station's going to be if we're looking for the null. Add our sense antenna. Then we can turn our sense antenna, the null on it, to the north and see what that does. And then we can turn it around to the south and we'll be able to tell for sure which direction it was, whether it's north or south.
Right. That makes sense.
Yeah. So you use both. You use the loop first, then you take a measurement with the sense antenna to say which one of the 2 nulls is the correct one. Pretty good idea. It wasn't my idea. I've got a question for you.
That's what I was afraid you were going to say.
What is a pennant antenna?
Oh.
A 4-element high-gain vertical array invented by George Pennant.
B, a small, vertically oriented receiving antenna consisting of a triangular loop terminated in approximately 900 ohms.
C, a form of rhombic antenna terminated in a variable capacitor to provide frequency diversity.
D, a stealth antenna built to look like a flagpole. I don't think it's D. Because that's totally out of character of what we kind of things we've been talking about tonight. A form of rhombic antenna terminated in a variable capacitor provide frequency diversity. I'm just gonna guess, man. I really don't know. I'm gonna say B or C.
You got to take one or the other.
I want to look. I'm not going to look at the chat room. I want to look, but I'm not going to do it. The triangular loop thing seems a little obvious. Maybe it is. I'm going to go with it. I really don't know. B.
They're saying B in the chat room, and I believe that's the
only
answer.
one that doesn't look like nonsense is B. That's kind of what I was thinking too.
And it is B. One side is terminated into a 900 ohm resistor. So if you think about that, that's kind of like a rhombic antenna, because you've got one wire above the other, then you've got your resistor in there terminating it. That's kind of like a rhombic.
How can the output voltage of a multiple turn receiving loop antenna be increased? A, by reducing the permeability of the loop shield.
B, by utilizing the high impedance wire for the coupling loop.
C, by winding adjacent turns in opposing directions.
Or B, by increasing the number of turns and or the area. How can the output voltage of a multi-turn receiving loop be increased? A, by reducing the permeability of the loop shield. That doesn't really make any sense. I mean, they didn't really say it was a shielded loop. B, by utilizing high impedance wire for the coupling loop. That seems counterintuitive. Using high impedance wire, that doesn't make sense to me. By winding adjacent turns in opposing directions, to me, I would think that would cancel it out rather than increase the gain. D, by increasing the number of turns and or the area. I mean, that makes more sense. You got more wire. I'm going to say D. Chat room.
D.
D.
3 Ds.
Yep, and
Some
it
of
is
them, the
D.
jury must have been out because there weren't a ton of answers.
Yep. One final question for
How many
tonight.
buzzers we got? One?
One. Here's your chance. You could make it an even number.
Two. No, that's okay.
What feature of a cardioid pattern makes it useful for direction finding? A, a very sharp peak.
B, a very sharp single null.
C, broadband response.
Or D, high radiation angle. The cardioid pattern does not have a very sharp peak. It does have a very sharp single null, though. And I'm just going to go straight for the kill here and go to B. But we know that's it.
Yeah, I think
We
I
just
think
saw
you're
it.
Yeah. Well, we didn't see the answer, but we saw the cardioid.
Wow.
And in the
So
chat
we saw
room, they're all saying B.
So pretty much saw the answer then,
Yeah.
if you paid attention.
A very sharp single null. Well, there you go. That is the answer. And that is the last question of the night.
Well, I would say that's relatively painless, but I did get buzzed one time.
You did?
I didn't even make a beverage antenna from it.
Well, maybe you need to start on the beverage antenna. Just work
Yes.
on it over a long time.
Nah, that's okay.
Yeah. Those weren't too difficult.
No,
Most
they
of
weren't
them
too
made
bad.
sense.
Yeah, there's a couple in there that were a little bit tricky, but it wasn't bad.
Study for your exam. We'll come back next month. We got the final group of questions, and we'll see you then.
Yep, 7-3,
7-3.
everybody.
Steve Kirker, W8SDK.
Stu Kirker.
Stu. What did I say?
Steve.
Steve? It's not Steve.
It's
Did I
Stu.
say that the whole time?
No, you said it right the first time. Second time you said it wrong.
Okay. Steve Kirker, W8SDK. Congratulations, Steve.
Stu. You already got 2 buzzers just on the email.
Yeah.
I think I'm ahead tonight.
Yeah.
I only got 1 buzzer.
Now, let me say that one more time. I'm not sure I'm capable.